For now, talking about some more North Dakota historical tornadoes, some of the strongest in our record books, and we don't have to go back too far. 17 years ago for this one in Rolla, north central North Dakota, an EF-3 tornado struck that town, leaving 12 homes destroyed, 18 were damaged, 3 people were injured. It was a 21-mile path length, so a relatively long track EF-3 tornado that lasted almost an hour, so it was pretty slow moving with peak winds of 136 to 165 miles per hour. And this is one photo just showing the damage to some of the homes. To get that EF-3 level rating, some of these homes were uninhabitable afterwards because of the damage inflicted by this tornado in early July 2008. So the supercell thunderstorm produced a couple of EF-0 tornadoes in southwest Manitoba around 2 p.m. that afternoon, and then the supercell tracked to the southeast over the Turtle Mountains. There was actually a little bit of terrain here too that it went over, but again, relatively long path length when the tornado formed at about 2:50 that afternoon and then struck Rolla, the north side of the city, specifically at about 3:30. So here was the weather setup on July 7, 2008 to produce this very strong tornado. Now, looking at the area of low pressure, which was right along the Canadian border, there was a dry line coming to the south of that and an outflow boundary to the southeast. So where all 3 of these different air masses meet, that's the triple point that can indicate where severe weather can happen. Now, the dry line separates dry air to the west from warmer, more humid air to the east, and the outflow boundary was really crucial in this case. That can enhance the spin and pull up some of the moisture and the instability in the atmosphere, and that's where the tornado tracked along. Rolla had a temperature of 71 degrees when the tornado came through with a 67-degree dew point, and the winds were out of the southeast ahead of the outflow boundary, out of the southwest behind it. That enhances that rotation in the atmosphere to produce the tornado. Chauncey Schultz with the Weather Service was working that day and brings us back to kind of the unique setup with this case.
So it was actually somewhat of a isolated severe thunderstorm threat. It wasn't a widespread severe storm threat that day because the early day showers and thunderstorms had kind of wiped out the energy for a lot of the area. However, right near the vicinity of that outflow boundary, this supercell thunderstorm developed in the early afternoon over southern Canada and headed to the east-southeast along that boundary. Relatively isolated, but as soon as the storm developed on radar, the lead meteorologist on duty at the time identified the rotation increasing significantly, which led to tornado warnings being issued as the storm moved across Rolette County.
So focusing on that outflow boundary, that was again the focal point to create enough spin in the atmosphere for the strong tornado to form and then track along it. And you can get these outflow boundaries from previous thunderstorms. The cool, rain-cooled air from those storms pushes out a gust of wind, and along that boundary that separates the cool air from the thunderstorm and the warm air farther away, the interactions of the different densities of the air can create spin in the atmosphere, and the slow speed of the tornado kept it along that outflow boundary where there's more wind shear and more instability, which are the 2 key ingredients for tornadoes to form. We can also use a more complicated weather term called helicity to describe how the outflow boundary enhanced the ingredients to form this strong tornado. So helicity is a measure of the amount of rotation found in a storm's updraft air. And these supercell thunderstorms can ingest this spin in the atmosphere and tilt it vertically to form some tornadoes when that spin is maximized near the ground. So if there's significant rotation, it'll likely become a supercell storm with that rotation aloft and possibly spawn a couple tornadoes. So the word helicity comes from the word helix, kind of like a spiral or corkscrew, with how those winds are rotating in the atmosphere. Now, there was a lot of research done on this tornado. Chauncey published a paper himself about how the boundary, that outflow boundary, impacted the tornado's movement. He used simulations to gain insight into the kind of environments that can produce other long-track tornadoes in similar situations, and he explains the importance of this type of research.
It gives us really knowledge and understanding of what kind of situations that can lead to strong tornadoes or violent tornadoes just like this one with later events. Helps us as meteorologists identify them and hopefully give folks a longer lead heads up ahead of those kind of events.
And speaking of other strong tornadoes, there was the Dickinson storm on July 8th, 2009. I'll be talking about that next week as I continue my Morse code weather tornado history series.
7, 8, 9. I'll never forget that day.
I remember the Dickinson one. The Rolla one, I'm a little
And to jog my memory.
Goes back in time, long
Yeah.
time. We were here, but it
17
goes
years
back,
ago.
Yeah,
Yeah.
long time ago.
Crazy.
Jacob, thank you
Thank
so
you,
much.
Jacob.
Good
You're welcome.
stuff.